These are notes 3.7. The first one we've kind of talked about already. The conjugate zeros theorem basically says if a plus bi is a solution, then I know there has to be a different one. Okay, the conjugate of it, then a minus bi also is a solution. Okay, we had said that these imaginaries always come in pairs because if you think about the quadratic formula, okay, we get these imaginary answers because this is negative, right? But if we have like 2 plus or minus the square root of negative 4 over 2, right? So if I have the square root of negative 4 is 2i, so we have 2 plus or minus 2i over 2, which simplifies to be 1 plus or minus I. So we have 1 plus I and 1 minus I would be answers, okay? So these imaginary answers always come in pairs because of this quadratic formula here, okay? So we want to write the cubic function, okay? So we're going to write out the whole function in standard form. If I know these are the zeros, okay, so if it's a cubic, I know there has to be 3 answers. So I know this is 1 answer, 2 answers, and then the third one, we know these come in pairs, so 2 minus I also has to be an answer. Now, to get it to write out to be the polynomial, I know my factors would be x minus 3, and I know this one would be x minus 2 plus I, and this one would be x minus 2 minus I. Okay, so what I'm going to do is I'm going to multiply these together first. Okay, actually I'm going to distribute the negative through first. So this would be x minus 2 minus I times x minus 2 plus I. And when I multiply these together, x times x is x squared minus 2x plus xi. Okay, then take the negative 2 through, negative 2x minus 4 minus 2i. Okay, and then negative xi plus 2i negative I squared. Okay, so if I simplify this, this becomes x squared minus 4x, and then some things cancel here, right? So there's all, and then I have this and this. Remember, I squared is negative 1 times this negative makes it plus 1, so plus would be I'm sorry, negative times a negative is a positive 4 there, right? So before plus 1, which would be plus 5. Okay, and then we have to multiply these together, and you take your x through and then your negative 3 through. You'll get x to the third minus 7x squared plus 17x minus 15 after you multiply that all together. Okay, so we have, if this cubic function has these zeros, has those solutions to it. Okay, now we're going to add one other little thing to it here. Let's say we want this equation to have these solutions, but we also want it to go through this. We want it to go through the point negative 2, 4. Okay, so I want it to go through this point and have these zeros. Okay, so I'm going to take this equation and I'm going to think about it like this. I'm going to say p of x is equal to a times this equation. So I have to figure out what this a is going to be. What do I have to multiply this all by to get it to go through that point? Okay, so I'm going to say the p of x is the 4, right? The output is the 4, and my input's the negative 2. So I'm going to put negative 2 in for all these x's. Okay, and if I evaluate this, okay, if I take this and multiply it out, it gets to be negative 85. So if I divide that over, I have a is equal to negative 4 over 85. Okay. Okay, so what I want to do then is take that and put it in right here. So my final equation is going to be p of x is equal to this times this, right? So negative 4 over 85 times this would be negative 4 over 85x to the third. Okay, take this and multiply it times negative 7. Would be a positive 28 over 85 x squared. Take it and distribute it to the 17. It would be negative 4 over 5x. And take it and distribute it to 17 to negative 15 gives me plus 12 over 17. So you can check this in Desmos if you'd like to. We know that this function, if you graph this, will go through the point negative 2, 4, and it will have these zeros. Okay, a lot of multiplying there. Okay, we'll do one more example. Maybe you want to try and do it yourself first and then tune in. Okay, so if I know this is 2 plus I know 2 minus I is also a solution, so we have our three answers there. So my factors that I want to multiply together would be x minus 4. Because remember how when you set this equal to 0, you get 4, right? X equals 4. Okay, and then we would have x minus 1 plus I. Then we'd have x minus 1 minus I. Okay, those would be my factors. Now, I always like to multiply these together first. Take the negative through. X minus 1 minus I. X minus 1 plus I. Okay. Now, if you do all the multiplying through there, yeah, I can do it. So x times x is x squared. X times negative 1 is negative 1x. X times I is xi. Negative 1 x plus 1 minus I minus xi plus I minus I squared. Okay, combining all those like terms together gives you x squared minus 2x plus 2. Okay, so a lot of the terms cancel out there. And then we want to multiply this all through, and if you multiply it all through, it gives you x to the third minus 6x squared plus 10x minus 8. Okay, so this function has these zeros. Okay, now if I wanted to go through the point 2, 4, okay, I need this function to still have these zeros, but to go through this point. Okay, I'm going to use that equation there and plug some stuff in. So my y is the 4, so 4 equals some number which I want to solve for, and I'm going to plug the x, the 2, in for all these x's here. So 2 to the third minus 6 times 2 squared plus 10 times 2 minus 8. Okay, if I evaluate all this, that comes up to be negative 4. And if I divide by negative 4, you get a is negative 1. Okay, so this one's kind of an easier one. So all I have to do is take that negative 1 and distribute it through to all this stuff here. So I know my p of x function is going to be negative 1 times x to the third, so negative x to the third. Negative 1 times this is plus 6x squared. Negative 1 distributed to the third term is negative 10x, and distribute it through gives you plus 8. Okay, so that is a lot of multiplying, but it's some good stuff. Okay, the fundamental theorem of algebra. We've kind of talked about this before as well. Basically, if it's x to the fourth, there's going to be 4 answers. If it's x to the 10th, there's going to be 10 answers. Okay, I'll write it out if you want to know the definition. If a polynomial of degree 1 or more, then at least 1, 0, and if degree n, then there's going to be n zeros. So they could be real or they could be imaginary. Okay, so basically I know x. So what we're going to do is we're going to find all the zeros here. So if it's x to the fourth, there has to be 4 answers. Okay, I know one answer here is going to be 1 minus I, which means another answer is going to be 1 plus I. So that's 2 of my answers. I have to find 2 more. Okay, so I want all 4 answers. So let's take these and multiply these together. Okay, so the factors would be x minus 1 minus I and x minus 1 plus I. Okay, and if I multiply that all together, okay, same way I did up on the top, I'll just tell you it multiplies to be x squared minus 2x plus 2. Just multiply it the same way we did all this right here. Okay? Actually, it's the same one we just did up there. Okay, anyway. Okay, so we know that this whole thing is going to be this times something else, right? Okay? Since these are factors of that. So we want to find out what this other thing is, and then we can solve this to get the solution. So let's divide it out. Okay, so if I take this divided by this, and to do that we can't use synthetic, we have to use long division. Okay, so the long division, what times x squared is x to the 4th? X squared. Remember, we multiply this. Gives us x to the 4th minus 2x to the 3rd plus 2x squared. And then we have to subtract them. So we draw the line and change those signs. So those cancel. That gives us negative 5x to the 3rd and 16x squared. And you could bring down the next term or two if you'd like to. What times x squared is negative 5x to the 3rd? Be negative 5x. So that gives us negative 5x to the 3rd plus 10x squared minus 10x. Once again, draw the line and change those signs. So those cancel. That would be 6x squared and minus 11x, and we can bring down that plus 12. And what times x squared is 6x squared? It'd be plus 6. Okay, that gives us 6x squared minus 12x. I'm sorry, that's 12 there, not 11. Minus 12x plus 12. Okay, notice if I subtract them, I get 0 remainder. So I know it's just this. So I know my factors are this one from the i's, and then this one right here. Okay, if I would multiply both of those together, I would get my original equation right here. Okay, so if I solve this one, I know that x is equal to 1 minus I and 1 plus I. Okay, now if I solve this one, I'm going to use factoring for this one. Be x minus 3 and x minus 2. I get x equals 3 and x equals 2. And right there I have my 4 solutions. Okay, so we'll try another one here. Find all the zeros for this one. So it's x to the 4th. So once again, there should be 4 answers to it. Okay, this is going to be a little bit easier because we don't have, it's just a single one here. But anyway, if 3i is a solution, I also know that negative 3i is also going to be a solution. So my factors would be x minus 3i and x plus 3i. Okay, so those would be the 2 factors there. And if I multiply these all together, that gives me x times x is x squared, being plus 3xi minus 3xi cancels out, and then that is minus 9i squared. I squared is equal to negative 1, so it's really just x squared plus 9. Okay, now I want to figure out it's that times what else will give you this up here, right? So I have to divide that out. Okay, so what times x squared is x to the 4th? X squared. This gives us x to the 4th plus 9x squared. Be careful here, make sure you put it right here and not with the x to the 3rds. So we can draw our line and change our signs there. Okay, so this would be an x squared, x to the third plus x squared. I can bring down that negative 9x plus 9. What times x squared is negative x to the third? Negative x, which gives me negative x to the third minus 9x. Line it up with the correct term there. Okay, add them together. Gives me x squared plus 9. What times x squared is x squared? Is a 1. Is x squared plus 9, and when I subtract, there's 0 remainder. So I know that x squared plus 9 times x squared minus x plus 1 will give me this right here. Okay, so when I solve these, I know this one gives me x is equal to 3i and x equals negative 3i. And this one here, it won't factor. So you have to use the completing the square or the quadratic formula. You can take your pick. I'll just use quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. This would be 1 minus 4 would be negative 3. And this would be 1 plus or minus I root 3 over 2. Okay, so there's your 4 solutions. We got these two right here and these two right here. So it's plus and the minus, okay, to give us our 4 solutions. Okay. Write a polynomial. Okay, so we want to write something like this, right? Write out the whole polynomial, having a 0 of 2 with a multiplicity of 3. What the multiplicity means is that x equals 2 is a solution 3 times. So our solutions are 2, 2, and 2, a 0 of 0 with multiples of 2, and a 0 of I. And we know if I is an answer, I also know that negative I has to be an answer too. Okay, so this one's going to be a lot of multiplying. So multiplicity of 3, so x equals, so if our factors of this would be x minus 2, and x minus 2, because it happens 3 times. A 0, so that would just be an x, plus 0 or minus 0, doesn't matter, is just x. And an I, so it'd be x minus I and x plus I. Okay, so now we just have to do a lot of multiplying of this stuff together. Okay, what I'm going to do is I'm going to take 2 of these and do this first. X times x is x squared, minus 2x is minus 4x plus 4. X times x is x squared there. Multiply these together, x times x is x squared. Minus xi plus xi cancels out. Negative I squared, and negative I squared makes that I squared is negative 1, so plus 1. Okay, so I still have to keep multiplying. If I multiply these two together, take the x through and then the negative 2 through, you get x to the third minus 6x squared plus 12x minus 8. Take the x squared through here, you get x to the fourth plus x squared. And lastly, I won't show all this work, but if you multiply all this together, right, I would probably go this way. Take your x to the fourth to all 4 terms, your x squared to all the terms. Well, I'll do it just to show you. So I'm going to take this through. So it'd be x to the 7th, be minus 6x to the 6th, plus 12x to the 5th, minus 8x to the 4th. Okay, now I got to take the x squared through, so that gives me x to the 5th, be minus 6x to the 4th, plus 12x to the 3rd, minus 8x squared. If I add all the like terms together, I get x to the 7th, minus 6x to the 6th, plus 13x to the 5th, minus 14x to the 4th, plus 12x to the 3rd, minus 8x squared. And there is my function. Okay, that function would have 2, 2, 2, 0, 0, I, and negative I as solutions. Okay, this one here, remember if it's 2 plus I, 2 minus I is also an answer. So my factors would be x minus 2 plus I and x minus 2 minus I. And then negative 3 with a multiplicity of 2, so x plus 3 would be the factor, and that happens twice. Okay, so I'm going to distribute through the negative here. And if I multiply these together, we did that a couple times up at the top, that's x squared minus 4x plus 5. Multiply these together, that's x squared plus 3x plus 3x plus 6x plus 9. Then take the x squared through, the negative 4 through, and the 5 through, gives you x to the 4th plus 2x to the 3rd minus 10x squared minus 6x plus 45. There's that function. Okay, number 9, we want to sketch this graph. So we'll look at a couple of different things here. What can we tell from this graph? Okay, so I'll just tell you this is equal to this. This is the factored form of that. So if you multiplied all this out, you would get this. Okay, so a couple of things we know. We know these are zeros, so x is equal to negative 4. And that happens twice. Okay, so it's going to be, remember how if it just came down and came back up, that counted as 2 solutions. Okay, we have that here, right? That's 2 of them there. Okay, we have x equals negative 3, and that happens once. And x equals 1 happens twice. Okay, so we know it's going to have to go through there. Now we also know if it's an x to the 5th, we know it's going to go opposite directions. Remember, if it was even, it was up, up, or down, down. But if it's odd, it goes opposite. And since it's negative, we know it's going to go like this. Okay. We also know the y-intercept is going to be negative 96. So if I plug zeros in for all these x's, I know y is equal to negative 96. I know it's down here at negative 96 it's going to cross. Okay, so the graph is going to have to look something like, remember this goes through twice, right? That was a double zero. And then it'll have to do something like this. I don't know exactly what that peak is. And then it's going to have to come down here and go through negative 96 on its way up to this. Oh, nope, hold on, that was a double zero, wasn't it? Okay, this is a double zero here. So this has to just barely touch and come back down. Okay, so we have the end behaviors correct, right? For negative x to the 5th, and we have all the zeros there. Okay, give this one a try. Okay, so I know it's an x to the 3rd. It's positive. So I know it's going to have to go like this for my end behavior. Also, I know that x equals negative 2. And that happens twice, that's a double zero. And x equals 3. And the y-intercept is negative 12. Okay, so if it has to have this, and this is a double zero, you know it's going to go like this, and probably hit this on the way up like this. Something like that. Okay, so we know a couple of things there from that. Okay. That's probably the notes of day 1. Here's day 2. Rational zeros theorem. Okay, so we want to know where could the possible zeros be. Okay, so this Desmos kind of makes it easy because you can kind of see some of them. But if you can't see it, this is how they used to have to do it. Okay, so we have P over Q gives a list of possible zeros. Okay, and I'll explain what P and Q are. Okay, so P are the factors of the constant, term, and Q are the factors of the leading coefficient. Okay, so this here is the constant term, and this here is the leading coefficient. Okay, so if I think about P is the 4, right? The factors of 4 would be 4 times 1 or 2 times 2, right? So it could be plus or minus 4, plus or minus 1, and plus or minus 2. Okay, those are all the different factors that, like negative 4, negative 1, give me 4. Positive 4, positive 1, give me 4. Yep, so the different factors there. The Q is the 6, and factors of 6 could be 6 times 1, or 3 times 2. Okay, so those are all those factors. Now, we're going to make a little table here with all the possible outcomes of P divided by Q. Okay, so P divided by Q could be 1 over 6, or negative, I'm sorry, that's not how I wanted to write it. 1 over 6, or the negative 1 over 6. Okay, so that took these two here, right? Could also be 1/3, or negative 1/3, or 1/2, or negative 1/2. Okay, so I took the 1. Also here, right? 1 divided by 1, it could be 1 or negative 1. So I took the 1 with all these here. Now let's take the 2. 2 divided by 6 is 1/3. But I already have 1/3 here listed, so I'm not going to repeat that again. 2 over 1 would be 2 and negative 2. 2/3 would be 2/3 and negative 2/3. And 2 over 2 is 1, and we already have 1 and negative 1 there. Take the 4. 4 divided by 6 is 2/3, we already have. 4 divided by 1 would be 4 and negative 4. 4 divided by 3, 4/3 and negative 4/3. Okay, and then 4 divided by 2 is 2, so we already have the 2's there. Okay, so these are all the different possible places where we could have zeros for this solution. Okay, so when I set this equal to 0 and solve this, these are the possible places where it could be. Now, if you want to find what the zeros are, the zeros happen, right, where it crosses your x-axis, where whatever the x is, you give the y of 0. So what you would have to do is take these and plug them in here for all these different x's, okay? So if I take 1/6 and plug it in here for all these x's, right, I would get 49/18. Okay? So that tells me at 1/6 it's at 49/18. So that's not crossing your x-axis. That's not a solution where it's equal to 0. Okay, so that's not a solution. 1/6, negative 1/6, when you plug it in there, gives you 5. So that's also not a solution. Okay, I'll just tell you the ones that when you plug them in, 1/2 works. That gives you 0. So that's a 0. Also, negative 1 is a 0. 4/3 gives you 0. Okay, and we should have 3 of them, right? So x to the 3rd. So we have our 3 zeros. So 1/2, negative 1. So in the solution, if I wanted to solve it, I know that x equals 1/2, x equals negative 1, and x equals 4/3. And you could use Desmos to find that as well. It should go right through at 1/2, at 4/3, and at negative 1. Okay. Okay, give the next one a try. There's less of them here than the other one. Okay, our P is equal to the 8. Actually, negative 8 doesn't really matter though here, because we we do all factors are always plus and minus. And the q is the 1 here. Okay, so all the factors of 8 or negative 8 would be plus or minus 8 times plus or minus 1. And plus or minus 4 times plus or minus 2. For 1, the only factors are 1 and negative 1. So negative 1 times 1 or negative 1 times negative 1. So all the possible values, if I divide these here, right, 8 divided by 1 would be 8, and then negative 8 because negative 8 divided by negative 1. 1 divided by 1 is 1 and negative 1. 4 over 1 would be 4 and negative 4. And 2 divided by 1 is 2 and negative 2. So these are all the possible places where I could have zeros. So I have to take these and plug them in for these x's to find which ones they are. And I'll just tell you that when you plug a negative 1 in here, it'll equal 0. If you take 4, plug that in there, it'll equal 0. And if you take negative 2, plug it in there, it'll equal 0. So I know that my graph will go through at negative 1, at negative 2, and at 4. Okay? And it's an x to the third, so I know it'll look something like this. Okay? Okay, try one more yourselves there. Okay, so the p is either 2 times 1, or that's the only factors of 2, of 6. I got 6 and 1, or 3 and 2. Okay, so then I got to list them all out. So 2 divided by 6 is 1/3, or negative 1/3. 2 divided by 1 would be 2, or negative 2. 2/3, negative 2/3. And 2 divided by 2 is 1, negative 1. Take the 1 through, 1/6. 1 divided by 1 is 1, but I already have those. 1 divided by 3, I already have 1/3. And 1 divided by 2 is 1/2. I don't have yet, so I'll put 1/2 and negative 1/2. So those are all the possible zeros. Take them all, plug them in here. I'll tell you that negative 2 works, and 1 works, negative 1/2 works, and 1/3 works. Okay, so I know that x is equal to 1/3, negative 2, 1, and negative 1/2 would be my solutions for where this is equal to 0. Okay. Okay. Right, Descartes' rule of signs. I'm not sure, man, this guy was smart to come up with this, to notice this, but he noticed if there's a positive number, the number of positive real zeros. So they were trying to think how many. So here we have the real zeros, right? How many of them are going to be positive versus being negative? So here we have 2 negative, 1 positive, right? So basically, he said this: if you look at the sign changes. Okay, so if we look at these sign changes, from here to here, this is a positive, that's a negative. That's 1 sign change. This is a negative to a positive. That's 2 sign changes. Positive to positive doesn't change. Positive to negative changes. So there's 3 sign changes. Okay, so he said that's the number of sign changes equals the number of positive real zeros or minus an even number. Okay, so this is saying since there's three sign changes, the number of positive real zeros is either 3, or if I do minus and even, so 3 minus 2, and even numbers 2, 3 minus 2 is 1. Okay, so there's either 3 or 1 positive real zeros there. Okay, Now, we could also look at the number of negative real zeros. Okay, so we look at the number of sign changes of f of negative x. Okay, so if we look at the sign changes of f of negative x. So let's say we take this one and if I want to find f of negative x, so p of negative x, remember how we did this in the past? We just put a negative in there, right? Okay, so this will be negative x to the fifth. That'll make that positive, times that would be negative 3x to the fourth. This one here makes that positive, so it'll be plus 2x squared minus x minus 1. Okay, so let's see how many changes. Negative to a negative is still the same. Negative to a positive is one change. Positive to a negative is another sign change. And then negative to negative. So this says two sign, okay? It's also this also or less by an even also holds here. Okay? So this says that therefore there are either 2 or subtract an even number, divide minus 2 or 0 negative real zeros. Okay? So if we wanted to use that to kind of narrow this down here, if we look at this, there are no sign change, one sign change, two sign changes, right, for the evens. Okay, so for p of x, there are 2 sign changes, so it'd be either 2 or 0 positive real zeros. And for p of negative x, okay, that would negative here makes that positive, so it stays 6x to the fourth. That makes that a negative 7x to the third. That squared is positive, be negative 12x squared still. Negative 3 times negative x would be a positive 3x plus 2. Okay, so let's see how many sign changes. One sign change, two sign changes, okay? So therefore, either going to have 2 or 0 real negative zeros, okay? And we see this here, right? So how many positive real zeros are there? One positive, two positives. Okay, so it has two positives, so we said is either 2 or 0. And then over here, the negatives, we have two negatives. So we had 2 positives and 2 negatives in that scenario. Okay, so that's Descartes' rule. Okay, last theorem here is the boundedness theorem. Okay, the boundedness theorem says if our c, okay, so this is kind of like our c is negative 1 here. So if I divide this out, if I have negative 1 here, and I divide this out, 2x to the fourth, negative 5x to the third, 0x squared, 3x plus 1. Okay, so if I divide this out, remember synthetic division, negative 2 be negative 7, be 7, and that would be what, 4, negative 4, and 4 gives you 5, okay? So if c is less than 0, which c is less than 0 here, and our synthetic division yields opposite signs, okay, so positive, negative, positive, negative, positive, okay, that tells us that there are going to be no zeros that are less than negative 1. Okay, so that would kind of help us out. If we had a whole bunch of a row of all of these and we use this theorem, we could say, okay, there's going to be none of them that are going to be less than negative 1. So it kind of eliminates some of them, so you wouldn't have to check all of them. Okay, now if our c is greater than 0, which 3 is, okay, let's again divide it out. So 2, negative 5, 0, 3, and 1. Okay, so now if these all yield non-negatives, okay, these are all non-negative, 0 is okay in there, okay, then we can say that there are no zeros greater than 3. Okay, so if you're thinking about, you know, if you have this huge long list of all these numbers here and you want to kind of narrow it down to where it can be, you can use the boundedness theorem to prove, you know, to get or eliminate some of them. Okay, that is notes 3.7.